Let's recap our factoring and zero product property or ZPP in class notes. So we did a little quizzes activity and we just went through and did, a little, manipulation here with a little bit of riddles. And we also split these up in class and kind of talked about we're just answering this question over and over and over. What multiplies to give me this number but adds to give me this number? The same two numbers. So for example, what multiplies to give me -6 but adds to give me 1 would be 3 and -2. Or, what multiplies to give me 48 but adds to give me 19 would be 16 and 3. And we just went through and looked at a bunch of different factors, different combinations even, one positive and one negative, two negatives, two positives, just going through and looking at all those different factors. And the whole purpose of looking at this page was specifically is then we pulled out a couple of these examples and applied them to why were we even talking about this? We were talking about those riddles because that's really the fundamental foundation of factoring as long as your A term is 1. So as long as A in front of your trinomial or your quadratic is equal to 1, then your riddle is kind of the key to that factoring then. So what multiplies to give you C but adds to give you B. So when we were pulling out the A, B, and C with the quadratic formula, that's also important here when we're looking at factoring is to identify our A, B, and C values. Because we're basically just going to fill in this riddle when we're factoring to say what multiplies to give me C but adds to give me B. Because our A term is 1, it leaves the setup so simple for our set of parentheses when we're setting up our factoring. So I just wanted to emphasize that as long as A is equal to 1, you set up your parentheses such as this because you're getting that x squared from x times x, just like you're getting k squared from k times k. What we're left with then is a nice shell to set up the rest of that problem to answer this question. So because we did these on the first page, we pulled out some examples of numbers that were personal to us. So this is for 7th period's A group. They picked 48 and 19. And what we said is that what numbers multiply to give you 48 but add to give you 19 are 16 and 3. Now, as we look through all of these examples, again, what we did is we filled these in. So 16 and 3. If you're using positive values, you're going to say plus 16 and plus 3 because we want these terms to make sense to say x plus 3 and x plus 16. And we talked about just making sure that the order isn't necessarily important as long as the signs stay in that parentheses. What I mean by that is if you look at this second example here where we have negative, what multiplies to give me -52 but adds to give me -9, then what happens here is I have a positive 4 and a -13. However, if I was to switch up this order, I would still leave that term -13 or x minus 13, and that second set of parentheses would be x plus 4. So the order isn't necessarily important as long as the signs stay the same. Now, as we were going through, I did offer this opportunity, and I'm saying I'm offering this because it is something we'll focus a little bit more as we look at different types of factoring, like when we start to switch up whether the A term or the leading coefficient is equal to 1. But I offered this opportunity for a quick check. You should always be able to answer a factoring question and know with 100% certainty, or at least, a good 99.7% certainty that you're correct by checking your insides and your outside terms. And what we mean by that is you'll notice these highlighted green and blue. These inside terms, if I multiply them together, and these outside terms, if I multiply them together, should bring me to that B term, including that variable. So when we say x times 3, that gives me 3x, and 16 times x gives me 16x, which brings me to 19x. It's part of the foiling process or our distributing. So we're just kind of checking the build there to make sure that we're getting back to our original trinomial. So we did run through a couple of different examples with factors, and we just talked about the fact that these would be our final answers. that, when all is said and done, when you're looking at, okay, well, like Miss B, what's our final answer? Our final answers would be one of these sets of terms, right? The set of parentheses here, these are the factors, and these would be your answers. This information down here is just the quick check, so it's not that it needs to be shown. I was just offering that as an opportunity. Now, this is factoring, and this is something that's done when you have examples that look like these. These are expressions, right? This is a quadratic expression, expression. They're all expressions because they have no equal sign. Now, what we talked about, or we recapped at the end of our notes, is that we are going to start to, build our factoring skills so that we're comfortable and confident to then be able to solve. And solving is just using that idea of the zero product property. And the zero product property states that if A times B equals 0, then at that multiplication, those terms can then be split up to be provided their own equal 0. How that works with solving then is if we had two factors, x plus 5 in parentheses times 2x minus 1 equals 0, we would be solving this because it's set equal to 0. If you're being provided a situation where you're set equal to 0 and asked to solve, then we would separate, provide each of those factors their own equal 0, and solve. The biggest emphasis I want to make is it's important to read directions and pay attention to whether you're being given an expression versus an equation. There are no equal signs here, so you factor and leave the parentheses. Because there is an equal sign and the direction says to solve, that's when we would take it all the way through. So we were just emphasizing the importance of recognizing whether the directions say factor or whether the directions say solve, whether you're given an expression or whether you're given an equation. Those are the big separations that we want to make. Now, for the rest of this video, I'm just going to go ahead and take you through and show you that after 7th period's A group, I also made sure the following day to give some voice and choice to 7th period's B group. So if you want to see some different types of factoring, 7th period's B group chose to do expressions like x squared plus 14x plus 48, providing some different factors, and then ending up with these answers of x plus 8 and x plus 6. Again, whatever in the order is not necessarily important there, but again, we even repeated this x minus 9, or x squared minus 9x and x squared minus 9x minus 52. So looking at that example. And then we went ahead and talked about, well, what if we change up this middle term, right? Earlier it said x squared plus 19x plus 48. Now we have x squared minus 19x. And what that does is that changes up the sign. So it's important to be careful. And this is also why I provided that opportunity to do that quick check if needed, to say, okay, what if I accidentally put 2 plus signs in here, right? What that would do is that would create a bit of an issue, because if I put positive 3 and positive 19, well, that would give me positive 48. If I did that quick check, it would give me positive 19, which would be a bit of an issue. So we talked about, paying attention to your signs. It's always important, and it's never a bad idea to check just to ensure that you're getting the right answer. So especially with factoring, you should be able to, with 100% certainty, turn in accurate factors. Again, we did some different types of examples with our 8th period A group. We picked out some different factors. They went, interesting here with doing, 8 times 7. 8. Oh my goodness, I wanted to do this in gray and it's not letting me. There we go. 8 times 7 and 7 times 8, and adding those together. So we did this quadratic trinomial. We did a really good one practicing, working with double negatives where both of our factors were negative. It's never a bad idea. Checking your signs. How am I getting a positive 55 but a negative 56? Oh, well, if both terms are negative, that's going to give me a negative when I add those together, right? And then again, we took the same example we've been looking at, and just mixed it up with the variables here. So a lot of times we're presented quadratics with x. I mean, we could use y, we could use b, we could use all kinds of different terms. But again, just constantly emphasizing the difference between an expression and equation. And lastly, not least, the 8th period B group mixed it up even more. And 8th period B even went as far as we made up our own quadratic because we used the factors of -3 and -14. So again, these are the answers to those factoring questions of, what would multiply to give you the C value and add to give you the B value. And again, the importance there is that just recognizing the difference between when do you stop, right? If we're just factoring expressions, we're stopping with those factors. If it says solve and there's an equal 0, then you keep going. And we'll keep working on that difference throughout. But our biggest focus was just being comfortable with recognizing that your A value is 1, setting up those factors, and finding the correct factors working with your multiplication skills. So hopefully this is some good review. Like I said, I just compiled all the classes together because we did pick some varieties of quadratic expressions just to give you some different examples to view. But hopefully this, helps to refresh or gives you some good information to start building your factoring skills. If you have any questions, as always, please ask.